How fast will the car travel off the cliff ledge? Note that the car is traveling horizontally when it leaves the ledge. To start with, I need to figure out what I know, so I'll make my list of givens. In fact, I'll make two lists of givens, one of all the variables that are in the vertical direction and one of all the variables that are in the horizontal direction. So vertically, or in the up and down direction, the initial velocity is equal to 0 because the car is traveling horizontally. It's not going up and it's not going down when it leaves the edge of the cliff. I know x naught, wherever the car starts the motion, that's going to be equal to 0. So in this case, that'll be the top of the cliff, and that's going to make x, the distance it travels, down to the bottom of the ground, and that's going to be negative 11 meters. The acceleration goes down as well, so that's going to be negative 9.8 meters per second squared. So there are all the givens that are going in the up and down or vertical direction. I could make them all positive instead of negative, just make downwards the positive direction instead of negative, and it still works. Horizontally, what do I know? Well, horizontally, I don't know a lot. I know the initial vertical velocity is unknown. I know the acceleration is equal to 0. That means the final horizontal velocity is equal to the same as the initial, which is unknown. And when it lands, it's going to land 6 meters away from the edge of the cliff, and that's called the range, or that horizontal distance away. Now I need a strategy to figure out what the horizontal velocity is going to be. Well, I know time can be used in both columns, so I'm going to find the time. And in fact, I'm going to start by finding the time using the vertical givens, and then I'm going to use that time I calculate with the horizontal givens to calculate the horizontal velocity. So I'll find the time with the vertical givens. I'm going to use my longest equation, kinematics equation, the x equals x naught plus v naught t plus 1 fat squared equation. Put in my values. I can do a little bit of math here until I finally get down to the point where t is equal to 1.498298355 seconds. So a lot of decimals there, but that's okay. Once I find the time, that means I know the time in the vertical column and the horizontal column. Because it's a scalar, it fits in both, which is really great. Now I've got lots of givens horizontally. So I'm going to find the horizontal velocity with the time and the horizontal givens. So I'll start with the x equals x naught plus v naught t plus 1 fat squared equation that I use. I know that horizontally x naught is equal to 0. It's always true. And I know my acceleration is equal to 0. So this comes down to something simple. X equals vx naught times t. So it's the range is equal to the horizontal velocity divided by the, or times the time, sorry. Now I'm going to isolate the horizontal velocity. That's going to be the horizontal distance divided by time. Put in my numbers. So I'll put in 6 meters divided by the time I just calculated. And I get my horizontal velocity to be 4 meters per second. So that's going to be the horizontal velocity.